Okay, so welcome back. So now we're going to do laminas that covers regions that are a little bit more complicated. Okay, for example, what if we're bounded by two curves, right? We've seen this before. So I'm not going to go through the entire derivation and how we developed the formulas for this, but so I'm not going to go through all the Riemann sums because I think you guys are already familiar with this and understand this, I hope, of what's going on. So what I'm going to do is I'm going to highlight and point out the important pieces and then show you how they fit together. So now, since we're dealing with a rectangle here that now is bounded above and below by a function, a continuous function, then the height of the rectangle is no longer going to be f of x. So the height of the centroid is no longer going to be f of x divided by 2, right? So now the height of the rectangle is now bounded by above by f of x and below by g of x. So the height of the rectangle is now going to be this. Okay? And again, we're talking about x sub star, right? So we're talking about the same x sub star on an interval, right? So again, I'm not going to go through the whole thing, but again, we have this x sub I minus 1, x sub I, and then of course we're defining x sub I star as the midpoint of the rectangle. So that's going to be x sub I minus 1 plus x sub I, oops, not x2, x sub I star divided by 2, okay? So then the height of this particular rectangle is going to just be x sub I star, like before. Okay, but now the height of the rectangle is the difference between the two functions. Okay. Now, also notice that the midpoint, the centroid, is located at x sub I star, of course, the midpoint of the base. But also now the midpoint of the height of the rectangle is now given by the midpoint formula for the distance between the two. Okay, so it's going to be f of x sub I star. I didn't put the I star in here. So it's going to be f of x sub I star plus g of x sub I star divided by 2. Okay, so that, again, that should make sense from our previous discussion. So now this is the centroid. So now, the total mass of the system is going to be, again, summing up all the rectangles, I equals 1 to n, and then this is where the mass comes in, so the density times area. So now it's going to be density times the area. Now the area of the rectangle now is what? It's going to be the area, the base, right? So that's going to be delta x, so that hasn't changed, right? It's regular intervals, subintervals, so it's going to be delta x times the height, right? So base times height. Well, what's the height? The height is going to be the difference between these. So the total mass is going to be, is going to be that. Okay. So that's going to be the total mass. Similarly, so this is going to give us the integral from a to b, right? As we take the limit of this, this is going to give us the integral, okay, rho times the integral of just f of x minus g of x dx. Okay, and then similarly, what do we get? We get the moment with respect to the x-axis. So again, it's going to be the mass, or excuse me, mass times distance. So now the mass, again, is given by the formula. So it's going to be the mass times the distance. Now in this case, the distance is given by this, right? We're doing that with respect to x, so the distance is going to be given by this. So what are we going to get? We're going to get rho, and we're going to get f of x sub I star minus g of x sub I star, right, times this, which is going to be what? F of x sub I star plus g of x sub I star, all divided by 2. And of course, we've got the delta x. Now notice that we've got this times this. And we're going to get, now notice it's going to give us a difference of 2 squares. We've got basically a minus b times a plus b, which is going to give us a difference of 2 squares. So this is going to simplify to, again, I'm going to pull the half out. So this is going to equal the summation of, for I equals 1 to n. So this is going to be 1/2 rho, and this is going to become f of x sub I star quantity squared minus g of x sub I star quantity squared delta x. And that's going to again, if we take the limit, that's going to give us our final answer, which is going to be rho times the integral from a to b of f of x squared minus g of x squared over 2 dx. And then of course, if we do a similar type of derivation with respect to y, well, what are we going to get? We're going to get the same thing. So we're going to get our mass, right, which is given by this. But this time, we're going to multiply by the distance with respect to the y-axis, which is going to be just x sub I star. So what happens is m sub y ends up becoming rho times the integral from a to b of x times what? Times this. So x times f of x minus g of x dx. And that's it. That's how we develop it. And so in the next video, I'm going to, again, just give you the theorem that puts all this together, and then we'll do an example. Have a great day.